This video outlines the procedures and steps necessary to shim the tail rotor head within the fork of the tail rotor shaft on all BK variants, up to and including the C2. A properly balanced tail rotor is essential for successful flight. For the tail rotor to be in balance, the center of gravity point of the rotor head must align with the center line of the drive shaft. We will cover the steps outlined in the procedure to obtain the necessary measurements, calculate the amount of shims needed to center the rotor head, and then install the required shims. After installing new shims, we will remeasure and check that the assembly is functioning correctly. Of course, you should always comply with the maintenance instructions outlined in the current aircraft maintenance manual. Should a discrepancy arise between this video and the AMM, the written instructions shall prevail. The following special tools will be required for this procedure: the pressing in and pushing out tool, the measuring device for the tail rotor shaft fork, and finally, the guide sleeve. Begin by removing the tail rotor assembly from the tail rotor shaft. During disassembly, make sure to thread the guide sleeve onto the end of the close tolerance bolt and leave it installed during the removal and eventual reinstallation of the bolt. Also, be certain to mark the parts during disassembly so that you may reassemble them in the same positions later. Take special care to mark the flange of the bushings, the outboard face of the spherical bearings, and the outboard face of the outer races. Be aware that if you need to install new bushings, you must hone the new bushings prior to reinstalling the bearings. Failure to hone the bushings will likely result in damage to the bearings. With the tail rotor head removed from the drive shaft, mark one side of the fork X1 and the opposite side of the fork X2. Now, remove both bearings from the fork using the pushing out tool. You will also remove any shims which may be present. With the old shims removed, press the bearings back into the bushings using the pressing in tool. Throughout the shimming process, you will need to remove and install the bearings more than once. For consistency, make sure they are installed in the same position each time. Now you may install the measuring device tool between the forks of the drive shaft. Keep in mind that throughout the shimming process, you will need to install this tool more than once. For consistency, the same person should install the tool and take the measurements each time. The order in which these next steps are taken is important to ensure accurate measurements. Start by threading the measuring washers out near the head of the locating bolt and knurl nut. Now unscrew the knurl nut with washer attached, remove the bolt. Place the tool between the forks and reinstall the locating bolt. Finally, thread the knurl nut with washer back onto the locating bolt and hand tighten. Now rotate the adjusting sleeve until the measuring flanges are seated flush against the inside surface of each spherical bearing and hand tighten. Finally, hand tighten the two measuring washers against the outside surface of the forks. With the measuring device tool installed, you can now take your measurements to determine the amount of shims you will need. Accurate measurements are imperative. The first measurement, A, is the distance between the outside surface of the two measuring flanges. This value represents the distance between the bearings in the fork. Our A measurement is 94.95 millimeters. The next measurement, X1, is the distance between the inside of one measuring flange to the outside of the corresponding measuring washer on the side of the fork marked X1. Our X1 measurement is 30.17 millimeters. The next measurement, X2, is the same distance on the opposite side of the tool marked X2. Our X2 measurement is 30.18 millimeters. The final measurement, B, is the distance from one side of the actual rotor head to the other. Our B measurement is 95.29 millimeters. With your measurements complete, you can now calculate the amount of shims you will need using the following process. First, subtract A from B. Divide the difference by 2. We'll call this our AB number. Put this to the side for now. Next, subtract X2 from X1. In our case, the difference is a negative number. But this is arbitrary since we determined which side would be X1 and X2. The empirical value is what's important. Therefore, our negative 0.01 becomes simply 0.01. Divide this number by 2. We'll call this value our X number. Now determine which measurement is larger between your original X1 and X2 measurements. For us, X2 is slightly larger. On the side of the fork with the larger measurement, add your X number to your AB number. On the side of the fork with a smaller measurement, subtract your X number from your AB number. These two results will be the total width needed for your shims on each respective side. So on the X2 side, we need our shims to equal as close to 0.175 millimeters as we can get using the available shims. Using 3.05 shims and 1.025 shim, we can reach this number exactly. Now, on the X1 side, we need our shims to equal as close to 0.165 millimeters as we can using the available shims. With 3.05 shims, we can reach 0.150. Now with your calculations finished and shims selected, you can press the bearings back out. Rotate the fork vertically and drop the shims into their respective bushings. Then carefully press the bearings in. Take care to keep the shims flat and centered. Now, reinstall the measuring tool and remeasure your A, X1, and X2 dimensions. In our case, A is now 95.29 millimeters. Because our B measurement is still 95.29 millimeters, we have a difference of 0, which is perfect. The new X1 measures 30.00 millimeters and X2 29.99 millimeters. We have a difference of 0.01 millimeters, which is well within the allowable tolerance. With the proper shims installed, the rotor head is now shimmed to center. Now, reinstall the rotor assembly. After reinstalling the close tolerance bolt, make sure to remove the guide sleeve. And finally, check the function of the flapping hinge. The tail rotor assembly should be free to flap with gentle pressure applied. It may help to remark the bearings, bolt, and bushings so that you can more easily see if the two spherical bearings are moving in concert with the tail rotor head and close tolerance bolt. Meanwhile, the bushings and the outer bearing races should remain stationary within the fork. This completes the process of shimming the tail rotor head. If you have any questions, please contact Airbus Technical Support